So welcome everyone. My name's Alex Jenkins. I'm the Director of the WA Data Science Innovation Hub. So we're very excited today to welcome you to our Data Science Discovery in Agriculture event. So the Data Science Hub is built to enable data science in WA. So we exist for the training and uptake of data science. So we hope to build an ecosystem in WA, encourage more students, more jobs, more economic activity. So the Data Science Hub was formed out of something called the New Industries Fund, which was a state government initiative in 2017. And the idea being that there were certain areas of the economy that we need to diversify in Western Australia. So, you know, there's every chance that we need to build that we could have a mining crash one day that would see large parts of our state budget in serious problem state. And we're looking now to diversify the economy, build out skills in areas such as data science, and it's going to be a big part of our future. We estimate that in the next 10 years, we're going to see 3,000 jobs required in the data science area, and that's across all industries. So things like healthcare, mining, Agtech, and many other sort of retail and consumer businesses as well. So I suppose the theme of today's event is what's happening in Agtech around data science. And we've got three expert speakers here today to tell you about that. My own experience in Agtech is quite limited, but I have someone who's almost my brother-in-law who has a farm down south. And I went down there and had a look. And he's not a really tech guy, but he likes to be on the kind of cutting edge of farming. And so he's invested in a lot of different technologies, and it really blew me away. And just because it's the kind of thing I like to do, I sat down and drew a kind of diagram of all the different data systems that he was talking about. And I've got it right here. It's on this old piece of paper. But it really blew me away. So he collects, this is someone who isn't a data guy, he's not a tech guy. So he collects rainfall data from, weather station and equipment on his farm. He collects information from his sprayer, so how much fertilizer he's applied. He collects information on the soil chemistry, get your soil tested and it comes back. And he collects information from his harvester. So that's things like, where the crops are, how fast things are going, the topology of his land, and the yield from his crops. Now, this is not someone who works in data again, and his challenge was to integrate all of this so that he could view it, in his mine management kind of software, bring it all together, and help run his farm in a more efficient way, help run his machinery in a more efficient way, and maximize the yield of his assets. And it kind of blew me away because this guy's a farmer, he's got no training in all of this, but this is about the same level of data that you would collect from an operating mine site. So my background is in mining. I was like, wow, this is about the same order of magnitude of data. And you would have teams of people looking after this. So I'm really interested to understand where we are with Agtech, what its adoption is in Western Australia, and the kind of technologies that we're using. So with that in mind, I think it's a real incredible growth opportunity for Western Australia. And I'm pleased to introduce our speakers today. So our first speaker is Wes Lawrence. Wes Lawrence will be talking about making agricultural data fair and fair. So Wes is the managing director of Actech. So Wes is originally from a mixed farming operation in Cranbrook in the Great Southern of WA. After juggling schoolwork and farm work, Wes spent a few years working for farmers and contractors across the districts and onto the two family properties, managing the day-to-day operations as well as operating earth-moving equipment, wool pressing, classing and running sheep and cropping programs. After moving to Perth to study and having a career in human services and then accounting, Wes became involved in technology, in particular hardware, software and data over RF. He worked in vehicle tracking and telematics, co-developed a wristwatch lone worker solution in the days before wearables became mainstream, and designed a sensor and communication system for luxury boating. Wes has brought together his knowledge of farming and farming operations, his understanding of hardware, software and data over RF, and the importance of data and data management into Actech. Wes and his team strive to deliver value to clients and deliver solutions that solve problems and improve business operations and efficiencies. So can we please join me in welcoming Wes? Thanks, Wes.
Thanks, Alex. Thanks for the great intro. So in terms of data science, I just want to give you a brief snapshot of a couple of interesting projects that we're involved with in varying degrees, playing a role within collaborative projects. So a couple of them are livestock related, and then some are more cropping and soil related. So one is working with a deep belief network that has an algorithm that's oriented around energy intake and energy burn for livestock. Another is around machine learning models within cropping and identifying soil restraints and constraints within season, within paddock, within crop and soil variables and delivery. Others that are around soil amelioration and optimization models and Monte Carlo optimization models, and that's a project that's in the pipeline. It's looking quite interesting. And then another which is very much at the edge, that is some neuromorphic learning, so a learning-based processor right at the very edge that's doing fusion sensing for biomimicry. I'm happy to have a further conversation on that, but it's a pretty neat little project. Fusion sensing basically being taking multiple sensor inputs, fusing them at the edge in order to arrive at particular measurements and outcomes. So why agriculture? And thanks for the great intro, Alex. Mixed farming operation that I grew up on in the Great Southern gave me a good backgrounding and understanding. Went off, did a bunch of interesting things, found myself in tech, and then founded Actech 5 years ago. And we're basically a whole of business operation in terms of the work that we do. So installation and sensors and cameras and RF and connectivity, device management, data and sensor data handling, visualization, data storage and data analysis. Australia and the world have some pretty significant opportunities in this space and some pretty unique challenges attached to that as well. There's a very significant number of farming businesses and industry associated entities and organisations. There's a very significant landmass that roughly equates to the mainland of the US that's managed, at least half of it is managed by primary producers. There's a very significant agricultural industry currently sitting somewhere in the 70s, depending on how this year's cropping program goes in terms of delivery, could be mid to high 70 millions, with a target of 100 million by 2030. And then globally, some genuine pressures around food production, around arable land constraints. So as Matt Damon in The Martian said, we're going to have to science out of this. So what are the building blocks in order to participate in some of those interesting data science projects? I'll bring you to a framework, a knowledge framework that myself and one of our producer clients developed called the 8 Pillars of Agtech. It began as something that I used to communicate with my staff internally. It wasn't this nicely structured and shaped and formed, and it's evolved to this over time. It's basically a peel back the layer and understand what's taking place underneath. Installation is very much about that. What's on the ground? Where are you? What are you trying to measure? What problem are you trying to solve? What's your geography? What are your constraints? What connectivity is available and so on? What animal proofing do you need? Weather proofing and environment. Those things are really important, as we've found out through lots of installs. There's all sorts of interesting animals out there that will have a crack at whatever you put out in field. Sensors. So in a real drill down, the sensor piece is the piece that generates the data. If you don't have the right sensor, you can't get the right data. If you want temperature, whatever the device is, whatever you're measuring, you need a temperature sensor. It sounds simple, but if you have a view of what it is you're trying to achieve and you can identify the sensor sets that are within that, then it gives you some language and methodology to be able to have a common conversation around that. Devices, they're the physical piece that does the powering, does the control, manages the comms, sets the cycle, does all the work at the edge, and they could be produced overseas, they can be produced locally, they can be in a variety of shapes and forms. Connectivity, there's lots of work that's gone in around solving some of these key connectivity challenges. Often solutions require multiple connectivities. They require a localized RF that comes back to a cellular that transmits over optic to then hit the cloud. Multiple technologies, and in understanding them, it gives a language to better problem shoot. And then we move on to data. And we separate, in this framework, we've separated out data ingestion from data storage, from data consumption, for the simple reason, and those of you here that are here because you're involved in data science, you understand the importance of the work that goes in that pre-processing, that pre-work in terms of data, and that well-organised, well-structured data is a dream to work with by comparison with whatever it is you might have started with. So we put that in the data ingestion piece. Data storage is important, and this really is drilling down into questions about what and where and who owns it and how's it controlled. On-farm consumption being that primary purpose of utilisation of data, and then off-farm and aggregated consumption being a final piece or a much more advanced piece with it. And often when solutions come together, someone will want to jump from a device to a dashboard, or jump from a property to an aggregated solution, but without really the comprehension that those internal steps are needed. So that's one part of a building block, is a knowledge framework. Social principles. Data is social. You guys working with data will know it. That there's a social contract that takes place in terms of interaction with people, between organisations, that is fundamentally social in nature, and it involves trust, and it involves permissioning, and it involves shared vision, shared project, shared value of some sort, and a transaction of value usually. We put this into a framework in terms of dealing particularly with producers, and again in collaboration with clients around understanding this control versus utility framework. External parties that are new to agriculture or are new to this space often look at it and go, oh, well, this is where producers should be. They should be willing to adopt any technology because of all the great benefits it will deliver. And there's some guys from DeepEarth that we've had a lot of conversations with about this, and they've encountered some of my co-collaborators, they might call them co-conspirators, in terms of clients that have a very different position in terms of that control piece in control and utility, where they sit very much at the other end. The reality is, producers are people, and this is where they sit. They sit in that entire range where some producers will happily sacrifice utility in order to maintain control because they believe there is value in data. They may not be able to articulate exactly what that value is, but they know there's value, and they don't want that horse to bolt. And equally, where there's plenty of participants out there that are willing to sacrifice control and don't really have concerns about control, they just want utility, just make the fucking thing work. That's what they want, they just want it to work. And so they're very much at that point of willing to trade off control in order to arrive at utility. I guess the principle and that social principle that we take is that producers want and need both. So in operating in this space, the social principle, the social contract is actually about delivering both. It's about furthering their own internal business value, furthering their own internal controls, their own internal capabilities, as well as delivering utility and not requiring a trade-off one to another. In terms of implementation and implementation principles, we've found that this framework of the fair data principles fits really neatly, and it operates internally as well as externally. Internally, findable, accessible, interoperable and reusable is very important in terms of being able to drive additional value internally within a business around data. Within industry, the majority of work within key businesses, and the reference to resources was there from Alex previously, there's a massive amount of work that goes into fundamentally meeting these principles, but it's internal within the business. There's databases, there's tools that sit over the top of databases, there's search functions, there's organisation, there's interoperability, there's cleanup work that happens. It's all about fundamentally reaching these principles. And then when you look at moving from that pillar 7 to pillar 8, so internal consumption to external consumption, these principles equally apply. Findable, accessible, interoperable and reusable. Our view of Agtech at the moment, and our sort of read of where things are at, is that there's key pieces of Agtech that are being uptaken en masse, lots of it's machinery driven. There's key pieces of Agtech that aren't. And the challenge, one of those key challenges bridging between innovator and early adopter and the early majority on that tech uptake curve is ROI, that return on investment. Reusable is the thing that delivers returns on investment. So if you can deliver multiple returns off of an investment internally within a business and have external utilization as well, your cost base does not increase the same number of projects that you run. Data is fundamentally reusable. It is not a finite resource, but that reusability gives the ability to drive multiple uses from that data that drives multiple returns. Part of that interoperability that sits there within the fair data principles, really a key piece of that is data standardisation. I was having a chat with Hans, who's kindly come across from South Australia just for this purpose. He's doing a Nuffield on data and from a wine perspective. And we've been having some interesting conversations, and Hans has a geology background. I showed him the framework that we're putting together of building out some data standards and some work we're doing with Uni Adelaide and SARDI. And he said, oh, in geology, there's the Field Geologist's Manual. It's an industry accepted book. This is an industry that's a few steps ahead of where we are here in ag. They've got a book. The book has standard references in terms of soil, in terms of geological structures, in terms of elements, standard names, nomenclature, units of measurement. It's just, you want to do something with it, this is how you do it. In ag and ag tech and data in ag, it doesn't exist yet. It'll evolve and it'll emerge, but it'll take things like this that are starting points of that conversation. Our data standards that we're putting together are an example of an application from within AgriFed. AgriFed being the Agricultural Research Federation, that are basically building a Pillar 8 framework for research data within agriculture. Really interesting stuff, worth having a little look at what they're working on. The challenges are for agriculture, there's lots around digitisation and other barriers to adoption. So this idea of agriculture, it's not unique in terms of an industry what is unique about it in terms of the need for digitisation. What is unique about it, though, is it is fundamentally a thin slice of lots of different industries. It's transport, it's machinery, it's chemicals, it's manufacturing, it's food and beverage, it requires traceability, where there's great learnings from pharmaceuticals, it's utilities and infrastructure management. It's not just about producing food, it's about managing assets and managing equipment and all of those things. So there's great learnings from other industries in terms of data and data management. These are some of the challenges that agriculture has. Data in inaccessible forms. It's still sitting in filing cabinets. We often talk about young blokes coming back on the farm and wanting to farm like this, and the reality is they're farming like this. Trolling through a filing cabinet to find some historical piece of information that in another business and another industry would be searchable, it would be findable. There's data in platforms, multiple systems. That's the thing that your brother was looking at, where there's lots of data, but it's fragmented. It's in lots of different platforms. That lack of uniformity and standardization, nowhere to store it, issues and challenges around data ownership, and so on. No easy way to collaborate and share with it. So a little bit of a framework of how we try and solve some of those challenges is about ingesting every single point of data we possibly can into a common data source, a common data point. It's about convergence of data. And this isn't a model that's unique to us. It's something that's adopted within industry. This is how industry does it. This is how oil and gas do it. This is how resources do it. This is how utilities do it. This is how big end manufacturing does it. Does that translate into small to medium manufacturing? Not yet, but we're working on it. It's an industry principle of data convergence, and it's just about taking some great tech and applying it into that space in order to be able to do it. The key elements to it is fair in terms of possession, ownership and control, and fair in terms of findable, accessible, interoperable and reusable. A reuse. You have a measurement, you have management, you can move to metrics. And so one reuse is having data-driven sustainability metrics. We're doing some work with the Global Farm Metric out of the UK. It's some neat stuff. It's one reuse of data. Within groups, again, a group is another social construct. It's a layering. It requires permissioning and relationships and trust. The idea of putting together a framework where you have members that have individual member controls with a data community, this collaboration framework, aggregated consumption within that framework, controls at a community level, and then the ability to engage at a broader supply chain sector, key elements within that framework with external collaborations. And the ability to physically transact and exchange data. And there's a few projects bubbling away in that space, and I'm not allowed to say anything, but just stay tuned on some interesting stuff that's coming out in this data exchange space. So, automating the mundane and supercharging the complex. You've got data, it's well organised and well structured. What are you doing with it? The framework that we put around this, we call it 111 to 333. It's basically breaking down knowledge, decision and action, and looking at human, machine-assisted and machine. Our discussions with producers is normally they want to jump from 111 to 333 in one step, but then they don't because they're afraid of what will happen if the machines take over. Now, neither is practical or pragmatic. The evolution is to simply evolve step by step. A dashboard takes your knowledge from human to machine assisted. You've gone from 111 to 211 at the point of the dashboard. The idea that you can generate a decision off a piece of data that's machine assisted. The machine makes a suggestion. The tank's at 20%. Well, that's machine knowledge. You should fill it up. That's machine assisted. Machine action is then when your machine can then deliver that in an automated fashion in order to arrive at that. But the ability to have a machine assisted decision where I swipe on my phone and I use technology and a machine in order to assist me in taking action is one interim point. If you're moving to complex generated knowledge and complex generated decision making, so automating the mundane is great. When you get to the complex, it's not so much about the machine doing everything, but about it being supercharged by machines. So farmers still want to farm, but they want data supported decisions, they want data supported analytics. And that's when we get to here. This is this piece around complex algorithms, complex pieces of work are about supporting that process of moving from 111 to 333. About moving to machine-assisted knowledge, machine-assisted decisions, machine-assisted action, and machine-generated knowledge and machine-generated actions. Very good. Thanks. Feel free to connect.
Thank you very much, Wes. Our next speaker is Grant Gilmore. So Grant is the principal from Beanstalk Agtech. So Grant is the Chief Data Translator at Beanstalk Agtech, whose mission is to unleash the potential for agriculture to be a leading force for good. Grant leads the digital team who are working with some of the most innovative agribusinesses in Australia on their journey to become resilient businesses of the future. Prior to Beanstalk, Grant spent 6 years at one of the world's leading consulting houses, the Boston Consulting Group, helping guide the strategic future of some of the largest and most innovative companies in the world. He was based out of BCG Perth, London, Stockholm, Santiago, and Sydney offices. He brings this wealth of experience coupled with a cattle farming background to support agribusinesses in Australia to leverage the best of digital innovation that's happening around the world, while also maintaining focus on their core business. Can you join me in welcoming Grant? Thank you, Grant.
Thanks very much. My name's Grant Gilmore, Principal at Beanstalk. I grew up on a cattle farm in Zimbabwe. We farmed Brahman and had an abattoir on farm, and at the age of 4 I worked in the knockbox. I moved here when everyone else did in the 2000s and took a very different career path, as was mentioned. But essentially the best, thank you, where's, flick over. I guess I got to see how some of the best and most innovative and leading businesses in the world from around the world use data to drive better decision making for their business. Growing up on a cattle farm, I knew we didn't do that as farmers. We generally went with a gut instinct that was developed, and generally quite correct, developed over years of experience, but very, very hard to authenticate, very hard to improve on, and very hard to pass on, quite frankly. I joined Beanstalk a couple of years ago. There were 3 of us. There's 10 now, based across Sydney, Melbourne, Perth, and Singapore. And our mission is to unlock the power of ag to be a leading force for good. What we mean by that is there's going to be almost 10 billion people in 30 years' time on the planet. That will require, so 5 billion of them in Asia, that will require 70% increase in food production because we like to eat protein, basically. It's a very inefficient form of transferring of energy, as we know. But 70% increase in food production, there's varying reports that say we're close to peak acreage in Australia, i.e. we're using all the available land that we have to produce food. Yet we're going to have to almost double how much we produce globally. And there's all reports saying Australia is going to be the food basket of the Asia Pacific region. We believe there is a way to do this, which is through innovation. So Beanstalk exists to solve this problem. I particularly solve this problem through helping producers use their data to make the best decisions possible for how they produce. And I'll share with you a couple of examples on that journey. In particular, how do we bridge this massive chasm between the data that we collect, which is significant, and the way we use it? So I'm not going to be so much talking about some of the ways we do it. Unfortunately, I know we're at data science, but I'm not going to be talking about regression analysis and advanced forecasting models today, but more just about what does it actually take to make data-driven decisions for the typical Australian producer, or for some of our clients, really. So I'm going to be talking about digital transformation, essentially, of which data and analytics is a core part, but it's not the only part of what it takes to get a company from using on-farm records to making data-driven decisions. Here's an interesting stat that lays out the challenge, but Harvard Business Review looked at the digital transformation spend across the US in 2019. It was $1.3 trillion. They estimated 900 billion of that, so 70% basically went to waste. It failed to meet its objectives. There are a number of reasons for that, but the three primary ones. Number one, the objectives actually just weren't defined clearly enough. Jumped in, started, but without an understanding of what the end goal was and what success looked like. We've all seen that before. Throw tech at a solution, throw tech at a problem to solve it. Which leads to the next one, which is new software was invested in either too early or without actually engaging the people in the organization and understanding what it can actually solve realistically, not just what it says it'll do. And then the third one is the big people, failure to engage the right people from early enough and all the way along the journey. Engage your own people. Those are the three big reasons. So what I mean by digital transformation is these 7 steps, the little boxes here. So define what your challenges are, define how it fits in your strategy and what actually success looks like. Bring your people on the journey, focus on your systems and your processes, collect, integrate, ingest, analyze your data, explore tech and devices, and then visualize and collaborate along that journey. This is the journey that we take our clients along generally. And I'm going to talk about 5 lessons along that journey that we've come across. Lesson number 1, in the define. Step 1, always start here. Invest a lot and invest heavily up front in actually understanding what your opportunities are. What are you trying to solve? What are your biggest challenges? For most companies, it's really, really essential to do this, to step back and do this. There's a real temptation to get in and say, oh, this solution is going to solve it. I know what we need to do. We need to do this. Step back and understand it. What does that mean? Here's an example, sanitized version of basically it's a heat map, right? It's a maturity assessment across a company's value chain, everywhere from irrigation through to grazing or growing animals. This is a livestock example, through to processing, trading, and then business intelligence across a number of lenses. So data capture, integration, your tech, your systems, processes, culture, and capability. Unsurprisingly, those lenses relate to the 3 biggest reasons that digital transformations fail. And you can clearly see in this example here, data capture, not so much of a problem, some maturity. It's the use of the data, i.e. this company is collecting enough data, but it's sitting on individuals' laptops. It's not working together. It's not being shared. Culture and capability are a weak point as well across some stages. This is another example. What I mean by your challenges, each bubble here represents a specific opportunity. And we've just mapped this with the executive management team. It's obviously sanitized. I can't share what all these examples are across the classic tech framework of desirability. How much of a pain point is this? How much do we want to solve it? Viability. How much is this worth to us? Impact is another way of saying it. How much money, what's the return on investment here? And feasibility. What would it take to actually do this? Can we solve it? You can see for this particular company, those big red bubbles, data and integration. It's their biggest challenges. 3.2 up there is a culture one. From memory, that was we need a single leader on site. Our general manager is actually based in Queensland, and we got 5 managers all optimizing for their own good on station. So this is what I mean by understanding what your challenges are. Now, innovation works best when you clearly define a challenge. We know that. It works even better when you're able to prioritize them. Prioritizing them means actually collecting the universe, ranking them, and putting them and understanding how they fit in your broader strategic framework. So we do this before we even start. This is a 1-month, 2-month process. Talk to every single person, get up on station, actually understand what the challenges are, get out in the field, understand what the opportunities are. Your people know best generally. They know your company better than anyone. And then define your objectives. I've kind of had tried to synthesize this a lot and keep it as simple as possible. So this could be a bit inflammatory, but I reckon, at least from my perspective, that end of the day for producers, your data should help you achieve one or all of the following three objectives, which is A, for a producer, it needs to decrease your cost of production. So using your data needs to help you do this. It needs to increase your certainty of revenue. You know, we talk about farming being the simple life. It is anything but. There are more variables than any other business I know of and I've come across, from the weather, from the animals, from diseases, from market prices and your people and culture, trying to get talent in remote locations. There are more variables than almost any other business. So it needs to give you your data, and your decision making needs to help you get certainty over your revenue. And finally, it needs to help you make better decisions in a timely manner. It's a bit of a catch-all bucket, really, but better decisions for your animals, better decisions for your people, better decisions for the money that you invest in your operation, and better decisions for your sustainability and your impact that you have on the earth and your land around you. It needs to help you do these three things. If you're investing in a solution that's not helping you do this, it's kind of just fun and games, really. This is the end outcome, and we need to get really clear on how any solution that we're going towards or that we're driving towards actually helps us do this. For example, decreasing your cost of production. You can't decrease your cost of production unless you know what your costs are, A, or if you know what's the impact of reducing those costs on my production. Will I get a decreased production as well if I switch to a different fertilizer usage? If I try increase the weight gain of my animals at a single cost, will that pay off actually in the long run? Will I be getting an equivalent value in weight gain or not for the extra feed that I'm putting down? So you need to be able to manage them in order to be able to decrease your costs. Flying through, number two, the most important driver. The most important driver is bringing the right people in your journey, on the journey from as early as possible. Trust your people, and this is ironic because I'm an outside consultant, but they know better than me. And my job is to help translate what they know into business decisions. It seems so obvious when you put it up there, but working with your people from day one through to day 100 or day 1000, whatever it might be along that whole journey, is the critical thing. Listen to them, understand what their needs are, understand what their pain points are, understand where they think the opportunities are. They won't be right 100% of the time, but they'll be right 90% of the time. They know better than anyone in the office or any outside consultant does. Your people know the best, know it. And at the end of the day, they're going to be the ones making decisions. They need to be invested in this from day one. This is what it looks like. The old TSI Gallagher, or TSI 2 there next to a Thompson Longhorn. This is in a crush. Cattle basically rush through there, and that's a weigh machine. And those levers there operate some gates where individual animals stand on a weigher and get weighed, which is a critical data collection point for any livestock producer. Understand what it means to actually tag an animal, look at its visual ID, understand what sex it is, look at its weight. If it's not getting through or it's showing it's a wrong visual ID, stopping everyone. It's a hot, dusty 40-degree day up there. What does it take to actually collect data? Because this is where it happens. And we all know if you get rubbish data, you get rubbish decisions, right? So why would a ringer or someone working on ground actually stop the whole process and collect better data? They need to understand what's the value in it for them and what it's going to drive for them. Here's another example, just to, your classic water bore gauge meter there. Understand the connectivity issues. So get up on site, talk to people, understand what it's going to look like. This has been an interesting one I actually didn't expect, but many problems initially identified as being data problems, i.e. we don't have the data, are in fact communication problems. They're not necessarily data problems. So what I mean by that is often when someone says, oh, we don't have the right information, you do. It just, the process to actually discuss it and collaborate it or get it interoperable, as Wes would say, and communicate it and be able to collaborate is not there. And what I mean by that quite simply is the meeting structure is not set up to discuss it. The format in which the data is collected, the frequency in which it's collected and cleansed is not there. The process is not there. So quite often we've found that most livestock producers, most farmers actually do collect enough data. Data collection is not necessarily the pain point. There's obviously more things we can do there. The cleanliness and the use and the process to use that is the biggest pain point for us through digital transformation. This is what it looks like. Jump on, get the team together weekly, fortnightly, make it really clear, it's in their calendars. We know from this meeting, we're going to discuss XYZ metric. We know therefore that a week before that metric needs to be updated. And a week before that, we need to be talking to the ringers or the graziers or whoever it might be to actually start getting that information and making sure that's happening. Lesson number 4. This is what I'm really passionate about. Are there any rugby fans out there? I talk about the backs and the forwards in data. The forward pack, you know, these ugly guys with big cauliflower ears, that no necks, and they look like rugby players. Their job is to get the ball to the line. And then the backs, these lovely boys with, you know, beautiful hair, gelled hair, they put the line over and score all the tries and get all the accolades. That's the visualization. So data collection, there's brute force grunt work in collecting, cleansing, ingesting, integrating data, analyzing it, forecasting it. But then you get the backs, and this is the most important point. You don't get the try, you don't get the points unless you put that ball over the line, which is visualizing it. So management, people can see this. Farmers need to be able to look at graphs, need to be able to engage with them. Without this point, it's kind of useless. And again, I'm being inflammatory, but you don't get the value out of it unless you actually visualize it. So present your data in a way that your organization can, and most importantly, does use. Again, bring that back to the people. Sit down with them, design a dashboard, and don't hand it over, go design it with them. Sit down in a room, understand, spend a day in the tractor with them. Spend a day walking out to the yards or condition scoring animals to actually understand how they would use this, what decisions they're making, and why that's important. Here's a station. This tells 1,000 words. This is Pardue Station, one of our clients. You know, I've shown you some pictures at the crush. It's only when you actually get the picture of what it actually means and you visualize it. The picture tells 1,000 words, right? A couple of Wagyu animals on that crush. Sorry, terrible graphics, terrible pixelation there. But here's some examples. Marbling score over time. What does that look per kill date? How do you interpret that? Do some forecasting, days on feed versus marbling score versus average daily gain, key metrics that drive profitability within a cattle operation or any livestock operation. Understanding your cost of gain. For every dollar that you invest, what's your return essentially? What is the gain you get? A kilo equals gain on an animal. What's the trends in that? How does that break down per breed or data group? Breed, sex, weaning year. What's your FTE efficiency? What's your safety metrics? Visualize your data, it's critical. And lesson number 5, and I'm gonna, in the interest of time, leave it there, but faster isn't better when it comes to digital transformation. It just isn't. Consultancies will drive fast digital transformations. That's because it's in their own interest to do so. That's how they make money, essentially. But for you and for producers, going slowly is actually in your best interest. It gives you time to define your challenges. It gives you time to bring your people along the journey, time to explore and properly do due diligence on any technology that you bring in. And it gives you time for your organization to come along the journey. To give an indication, I'm not talking about 10 years here, I'm talking about 2 to 3 for digital transformation, from depending on your size, your scale, and your scope. But you're not going to get it done in 12 months. Realistically, you're setting yourself up for failure. But 2 to 3 year journey, depending on how mature you are, is realistic. And I think that's a really good assumption that we work with our producers, and it's worked really well for driving great outcomes for them. Anyway, my name's Grant, Beanstalk Agtech. I hope to see you afterwards. Give us a shout if you have any questions.
Thanks so much, Grant. Okay, our next speaker is Dr. Darren Hughes. Darren has more than 20 years' experience in the Australian grains industry. Darren's family farm is near Geraldton. They grow wheat, barley and canola. He holds a Bachelor of Agribusiness and a PhD in crop agronomy from Curtin University. Darren has worked for several companies, from startups to large national research and development organisations. Prior to founding Laconic, he was a General Manager at the Grains Research and Development Corporation. As General Manager, he managed a portfolio of projects which had annual investment of $12 million and conducted research in agronomy, soils, farming systems and crop nutrition. Darren's expertise in managing complex systems, building and leading teams, developing and executing strategy, and his extensive network throughout the Australian grains industry is critical to the success of Laconic.
The way we make a fertiliser decision has changed very little as a concept in the last 50 years. And essentially at Laconic, we believe today's fertiliser decisions are far from perfect and that there's got to be a better way. Laconic was founded in 2017 by Wayne Plusky and myself, and it really started when I was the GM at GRDC. One of the projects I had to go and scope up at that time was a new investment in crop nutrition for farmers here in WA. And I contracted Wayne to come in and undertake a bit of a gap analysis of where the problems are that are restricting the profitability of farmers and what the technical solutions that needed to be overcome. Wayne spent a couple of months talking with the researchers and the consultants and the growers. To cut the long story short, GRDC and industry went and contracted a $15 million 5-year project. Wayne and I walked away with the inherent knowledge of the problems that the farmers had. Wayne, I guess, is a nationally recognised fertiliser expert. He's developed most of the mathematical models, or I guess the early stage data science and models that we use, that essentially work out if we apply 1 kilogram of fertiliser, how many kilograms of wheat will it grow? The one problem with Wayne and I is that we do not know how to write a single line of code. And it's very hard to run a tech company and a data science company when you don't know how to code software. So luckily enough, in 2019, John joined our team. And together it's the three of us that have really taken this idea and got the business to where it is today. Problem. So we're looking at fertiliser now from, yes, the profitability angle, but certainly this carbon angle that's really starting to show up now. So outside livestock, it's the fertiliser that really has a big problem. And about 1.5% of total global emissions of carbon come from fertiliser. Roughly 6 billion tonnes of carbon is put into the atmosphere through the production or use of fertiliser. Nitrogen is the most important element that a plant needs. If we take urea, which is the most common nitrogen, it's generally considered that only 50% of what farmers apply is used by the plant. So if a farmer puts 100 kilos on per hectare, the plant will use 50 kilos. The remaining 50 kilos disappears into the atmosphere, where it can go off as a nitrous oxide, a gas 300 times more potent than carbon dioxide. So we're looking using our technology now to not only measure the profitability component of fertiliser, but how do we start to reduce carbon emissions from fertiliser? And this is what we're sort of seeing. So we're sitting at about, based on our calculations, about 16 million tonnes of CO2 equivalent comes from the Australian fertiliser, which is roughly a 50% increase since about 2010. With the world making predictions to really cut carbon emissions by 2030 and to be carbon neutral by 2050, we've got a long way to go. And it's time for us to really start to look at the implications that fertilisers are having. This is the general process that we've come up with. So imagine that this circle represents the continuous improvement cycle in business. From a financial planning point of view, farmers are really good at planning the financial performance of their business. They're really good at implementing those financial plans, and they're really good at measuring the financial performance and benchmarking their performance to others. If I flip that around though and look at it from a fertiliser perspective, farmers are really good at planning how much fertiliser. They are hyper efficient at the logistics of putting fertiliser on. They've got no idea about whether they're making money out of this or the effects that it's having through the carbon emissions component. So essentially what we have created at Laconic is a simple and easy way to measure whether farmers are making money out of that. And to put some understanding about that, in 2019, 2020, Laconic did nearly 100 farmer scale trials in partnership with clients. I think the average loss over all those trials was about $46 per hectare. There's a lot of money being lost out there simply because farmers don't know whether they're making money out of fertiliser. This is what we've come up with. This is what John has built. Essentially, there's our two major products. We've got Laconic Combine and Laconic Trial. So behind this sits a web-based portal that a farmer can log on, share their data with us. And what we need is their paddock boundaries, They're A-B lines, and their A-B line is essentially just what drives the machine up and down the paddock in nice straight lines. And we can ingest their historical yield data. We've got two major products that we sort of put into the market. Laconic Combine is just a small plot trial over a whole paddock. So if I take just one of those individual green squares, they're roughly 50 metres long by 36 metres wide. And what Laconic Combine allows us to do is to actually measure spatial variability across paddocks in a way that we could never do it before. We believe this year we're running Australia's largest fertiliser. Understanding the profitability of fertiliser, we've got roughly 20,000 plots out there, and the data from that trial work is just starting to come in now. The Laconic trial example, farmers have been doing strip trials for a long time, and the ag industry's been doing strip trials for a long time. Each one of those plots is roughly 200 metres long by roughly 36 metres wide. All we've done at Laconic in that sense is simply made it easy for the farmer to put a trial in the paddock and measure what they're doing. So if you don't know a lot about farming and how it works, basically you cannot buy a machine nowadays that doesn't have the hardware and software that enables a variable rate fertiliser application. And essentially that's all we're doing. We can create a shape file that gets uploaded into the rate controller, the operator pushes the on button, and then the machine just does exactly what we tell it to do. The picture on your right there just goes to show the accuracy of the application of the data. We set the machine up to run down the centre of the plot, and it just does what we do it. The different colours that you can see as it's progressing through the plot is just slight variations in the application rate that we see. The big orange strip you can see, this was just an untreated control from this particular trial. We've done a massive amount of trials this year, and we now know that the capability and accuracy of the machinery to do what we tell it to do and to put the trial out in a very accurate way can be done. What we introduced this year was the ability to do trial monitoring. We had some feedback that we had to create value to the farmer during the entire growing season. So what we did is every time that the satellite goes over, we can take a measurement out of each of the individual plots, we can run the statistics over that, and we can measure whether there's been an in-season response to that fertiliser. So in this particular example, if I look at the individual squares and I take those sort of green squares, for example, they actually correlate with the blue dots in the middle. And that green square was simply the untreated control. So what we're able to do now is we're able to pick up and see the crop responding. And the picture on the right is just a validation that when we go out there and put a drone over it, you can really see the untreated plots coming up. The feedback that we had from our agribusiness clients this year is that it gave the agronomist a really good reason to go out in the paddock and have a conversation with the grower about fertiliser decisions. Was anything happening? It was a new piece of information that they could go out there. Even if they didn't sell the farmer any more fertiliser, it gave them a conversation to go and have a look at the crop. And it was something new that they hadn't sort of seen before. At the end of the season, and what's really sort of happening now is that basically every harvester has a sensor on it. That technology's been around for 25 years now. As the harvester moves through the plot, it just simply records a data point. So I think on the new Generation 4 monitors that sit in a lot of the John Deeres, they're basically recording every 2 seconds as it moves through a plot. So the ability to generate massive amounts of data for analysis now is huge, simply and easily. At the end of the year, a lot of farmers have a John Deere account or an AFS account, which is just a global platform where they store a lot of their data. We can sync Laconic into those global platforms now. We can automatically draw down that data, and we can run the statistical analysis over that data. So when I think about where does Laconic sit in the global ag database hemisphere, we're not in the collection, collation and connection of data. The big fertiliser companies and the big machinery companies have already beaten us. We're the company that plugs into that data, and I guess we're the smarts. We analyse that data and really help with that fertiliser decision and the profitability decision. Once we've got the data out of each one of these little squares, essentially what we're able to do is to go and calculate the fertiliser response curve. Mathematical equation of how plants are responding. In the past, when we've done fertiliser trials, we might do a trial in a very small fashion way, a plot that's 20 metres long by 2.5 metres wide, replicated in the bottom left-hand corner of that paddock. And then we'll try and extrapolate that result across the whole paddock. And we wonder why we're getting poor fertiliser decisions. The further we move away from that point, the exponential error that grows up, that goes. What we've got the capability now doing the laconic combine is actually embrace that spatial variability and measure it in a very simple and easy way. From there, we're producing a profit gap map, so we're able to show growers where they're under-fertilising and where they're over-fertilising. We're just starting to work on the carbon component now, so what are the carbon emissions components from there? We make, an internal assumption that the economic optimum decision is the environmental optimum decision. So it's once the grower starts to apply fertiliser greater than the economic return, there's going to be a waste to the environmental component. And what we want to try and ultimately turn that into is the economic optimum fertiliser rate decision for the grower. We're in the early stages. We've just finished, so 2021 is probably year 3 of our R&D commercialisation process. The next stage that we want to get to is start to employ the machine learning components. And how do we get more predictive in our fertiliser decisions, and how do we start to embrace those other sorts of data that Alex talked about from his brother-in-law, the weather data, the climate data, all of that ultimately influences a fertiliser decision. And we want to use that to create an optimal fertiliser rate. If I get back to the carbon point, we're expecting, so this is from our own internal modelling, we're sort of thinking that by 2030, carbon emissions from fertiliser are going to be in the order of 25 million tonnes. It's about a 60% increase on where we are today. We think that if we start to employ the laconic technology and we start to measure and monitor what we're doing, that we can probably reduce carbon emissions by in the order of sort of 10 million tonnes over the next 20 years. If you've liked what you've heard, happy to take any questions or catch up at any stage. Thanks for your time.